Good morning, Matrix. The theme today is sheep, and for that reason I have shared my head, and we have our guest today in the studio to help us out is Cara die Skaap. En Cara die Skaap se vriende en vriendinne noem haar Skara. Skaap, wie se naam is Cara, is Skara. So baie dankie Skara om in die studio in te kom. Ons is baie grateful dat jy hier is en jy sal ons help met hierdie normaal distribution se werk. Right. Okay. Back to less pressing matters, and please, we're on page 187 of your worksheets. You shouldn't have your textbook open. Okay, and we are going to complete these. You can either complete it with me, or you can go back. Probably better is to go back and do it by yourself and check that you can get that all sorted on your own. Okay, so righty then, here we are. Okay, so the question says, so now, up to now we've always been given the mean and standard deviation, and then either the area or the x-score, and we've had to go find either the probability or the x-score that goes with it. Now we're going to be given x-scores, and then we have to go find mean and or standard deviation. Okay, x-scores and probabilities. So it says here, it is often the case that we're required to find the values of mu and standard deviation sigma. Okay, and we will be given information, about areas, probabilities, and x values, and then asked to find mu and or sigma. Right. So the first question: the vitamin C content in milligrams in citrus juices is believed to be normally distributed with a standard deviation of 22 milligrams. So always to start off and summarize what we're given. Okay, we're looking at vitamin C content in oranges, and in an average orange, the standard deviation of the amount of vitamin C is 22 milligrams. And it is also known that about 15% of citrus juices, okay, contain a vitamin C content of more than 120 milligrams. The question is, go find the mean amount of vitamin C content, not in oranges, okay, in citrus juices. Okay, vitamin C in juices is what we're looking at. So again, always start off with a picture, even if you don't know exactly what's going on, of a normal distribution, and we're going to look at x scores and z scores. Okay, we know that for the means the z score is 0, and now let's have a look at this information here. 15% of citrus juices, so the probability is 0.15, have a vitamin C content of more than 120 milligrams. Okay, so it must be to the right because it's only 15% or more than that. If it's to the left, it'd be more than 50%. So this region over here, it goes with an x score of 120 milligrams of vitamin C. Is over here. Okay, so that area over there is 0.15. Skaap, do you agree? Yeah, Skaap agree. Or Skara say agree. What is agree in Afrikaans? Terrible. Right, okay. So that area over there is 0.15. Now, what we're going to have to find is we're going to end up using always this formula, Z is equal to X minus mu over sigma. Okay, so at the moment, we know sigma. Okay, we're looking for mu. Okay. We've got an X score of 120. We're going to use that X score of 120. Okay, and we've got to go find the Z score. Okay, because then I'll have all three variables except for mu, and then I can sub in and solve it. So I need to find the Z score that goes with this 120 milligrams. Again, your table has to deal with this region over here. So that's going to be H of 120. which is the area. So we're going to have, and this area over here is h of 120 is 0.5 minus 0.15, which is equal to, so 0.5 minus 0.15, I don't know why I'm using a calculator, it's 0.35, okay, is 0.35. So this area over here is 0.35. Okay, in other words, the probability that x lies between 0 and 120 is equal to 0.35. Right. So now we've got to go look up an area of 0.35 and find the z-score that goes with that. Okay, and it should be, if you think about it, that's about 35%. Remember, about 68% lies within one standard deviation of the mean. So unless my brain's rotten, it should be almost one exactly. Right, so I'm going to go look up an area of 0.35, and 0.35, well, that's 8 away, that's 15 away, we can go with that. That's close enough. 0.35, I wouldn't worry about being the middle because that difference is too big. So the z-score we're going to use, as we predicted, is just over 1,04. Okay, so this z-score over here is 1,04. Okay, so you don't have to write this down, but the probability that your z-score, okay, lies between, sorry, this x shouldn't have been 0. That is between mu, we're looking for mu. Probability that x lies between the mean and 120 is 0.35. The probability that z lies between 0 and 1,04, you don't, as I say, you don't have to write this down, is 0.35. Okay. Right. So that's all our x scores. That's all our z scores. Right. And now we're going to sub it, the things that we know into this formula. And we're going to try and find sigma. So let's put, for a change, just to the numbers first. So z is 1,04. And the x score that goes with that is 120 minus mu over sigma, and sigma is 22. So therefore, I'm going to have, if I move 1,04 times 22, okay, minus 120 is equal to negative mu. So mu, if I divide everything by negative, is 120 minus 1,04 times 22. So mu ends up being equal to, okay, you don't have to show any steps, you can go straight from there to the answer if you want. Okay, and we're going to get 120 minus 1.04 times 22, and we get 97,12. So in other words, the mean amount of vitamin C, blah, 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 vitamin C equals 97,12 milligrams in your average fruit juice. Okay, let's just check we are right in the textbook. Indeed, we are correct. Skare, ek is baie trots op jou dat jy hierdie som korrek gekry het. Okay, baie goed. Right. Okay, so that is example 7 done. Right, example 8 says economic data show that the total vehicle sales in South Africa fluctuates around an average of 45,800 vehicles per month. 4 months out of every year, the sales drop below 40,000. Supposing that the sales are normally distributed, what is the standard deviation? So we're looking at vehicle sales. Okay, right, and what are we given? Okay, this time we're looking at vehicle sales per month. That for vehicle sales per month, mu, on average 45,800 vehicles are sold per month. Then they tell us this information over here. 4 months out of every year, so in other words 4 out of 12, the sales drop below 40,000. So if we start drawing our diagram and we look at x scores at the top, first of all we know that mu is 45,800, and that's going to go with a z-score of 0. Okay, and then we know that 4 months out of every year the sales drop below 40,000. Well, 40,000 is over here. 40,000 is here, and 4 months out of every year the sales drop below 40,000. So we're looking at this area over here. What's the probability of the sales dropping below 40,000? Okay, so the probability X is less than 40,000. Well, it happens 4 out of every 12 months, which is 1 out of every 3 months, which is approximately, so the probability that X is less than 40,000 is equal to 1 divided by 3, which is 0.3333. Let's do it. Yeah, get quite a lot. This is area, and we get about 4 decimal places, at least even 5, okay, in that space. So let's do it to 4 decimal places, okay, when we're working with area. So that's 0.3333. Right. Now, Scarpy, can we use that? Correct. You cannot. Okay, you've got to go use this area over here. So that's 0.3333. So this area here is the area that we're going to use if I want to use the table. And that area over there is going to be equal to 0.5 minus 0.3333, which is going to be 0.5 minus 0.3333, and that is going to be 0.1667. So that's that area there. Okay, because what's our objective now? We want to find the Z-score. Why do we need the Z-score? Because in the end, remember, we're looking for mu, and we're going to use the formula Z is equal to X minus mu over sigma. So we're looking for sigma, the standard deviation. So that's what we want. We've got mu, we've got an X score, and we need the Z score. Those two things have to be from the same point, eh? The Z and the X score must be from the same point, the same scenario. So they've got to become from that situation over there. Okay, you can't have a Z score for something and an X score for something else. They've got to come from the same region, because that's what the formula does. Right, so I've just got to find the Z score that goes with us, and then I can shove that into that formula. So I'm going to look up an area of 0.1667. Remember that your Z is going to be negative because it's to the left, right? So 1,6667, 0.1667, well, that's pretty darn close. Okay, there is 0.1664, so that's going to be 0.43. Okay, so this Z score over here, okay, is going to be equal to negative 0, why am I feeling nervous about this? 0.5 minus 0.167. So I'm saying Z is negative 0.43. Just I want to check that that was correct. Okay. Yep, I'm right. Okay. Right, Scarpy, you should have reassured me. Right, so Z is equal to negative 0.43. Right, so that's the Z score that we've got that goes with the 40,000. So now I'm working with this point over here. 40,000 is my X score. My Z score that goes with it is negative 0.43. Okay, so now I use this formula. Z is equal to X minus mu over sigma. I'm looking for sigma. The question said go find the standard deviation. So if I manipulate the formula, sigma is going to be X minus mu over Z. So sigma is equal to an X score is 40,000. Okay, minus mu is 45,800. Minus 45,800 over my Z score, which is negative 0.43. Lob that all into your calculator. En Scarpy, sê vir my, wat kry jy in 40,000 minus 54,800? Okay. Over negative 0.43. Remember, standard deviation and mean can't be negative. And I get a standard deviation of 13,488,3 vehicles per month. Okay, which is a pretty high standard deviation, 0.37 if we went to 2 decimal places. And that's how much, on average, your vehicle sales fluctuate from the mean. Okay. Right, we're doing well, we're doing well. Okay, and that one was correct. So let's check. Okay. By the way, I don't sit and read the textbook when I do these. It's boring to do that. Got to do the sums yourselves. Right, copy. Right, last question, example 9. It says, an experienced high jumper knows that he can clear a height lower than 1.59 meters once in 5 attempts. He also knows that he can clear a height of at least 1.86 meters once in 8 attempts. Assume the heights are normally distributed. Okay, so we're looking at heights of a jumper, of a high jumper, and we know they're more normally distributed. The question says we've got to find both the mean and sigma, the standard deviation. Okay, right. So let's start off and draw diagrams of what's going on here. And there are 2 scenarios we get given in this case. Okay, let's have our x scores. We're looking for mean. Our z scores, that is naught there. Start off like that. All right, and we're told you can clear a height lower than 1.59 meters once in 5 attempts. Okay, so I'm looking to the left, and it's only a probability is 1 out of 5, so I must be working somewhere around there. Okay, and we know that this probability over here, okay, you can clear a height of at least 1.8, you can clear a height lower than 1.59 meters once in 5 attempts. It's a dumbass question, okay, but let's just go with it. I mean, okay, it's okay if you're worried about athletics, but mathematically it's fine, but athletics wise it's a bit lame. Okay, forget I just even said it. Right, so if I look at a height of 1.59 meters, his probability that he can clear it, okay, happens once in 5 attempts. Okay, so this probability here, so the probability that x is less than what he clears less than 1.59 meters, that happens once in 5 attempts, which is twice in 10, which is 0.2. So this area over here, okay, the probability that he gets less than that, clears less than that, is equal to 0.2. So this area here is 0.2. Okay, and then the next bit of scenario, that's our x scores. The next scenario we're given, you can clear a height of at least 1.86 meters once in 8 attempts. So if I go to 1.86 meters, this probability over here, okay, is going to be, so this is this information over here, okay, this area here, so the probability that x is greater than at least, so it's greater than 1.86 meters, happens once in every 8 attempts. Okay, and once in every 8, let's get that to a decimal. 1 divided by 8, and its area, so let's get it to 4 decimal places. Well, we can only do 3. So this area over here is 0.125. Okay, right. So I've got that equal to 0.125. That's the probability of getting bigger than 8.6, and I've got that scenario over there. And that can help us to get 2 equations. So to find 2 variables, we generally need 2 equations. In both scenarios, I'm going to use the formula z is equal to x minus mu over sigma. And in both scenarios, I've got to find the z score that goes with that 1.59, and I've got to find the z score that goes with that 1.86. So if I look at this side over here, okay, I can't use that area there of 0.2, so I must use this area, the table. I'm going to have to use that area, which is going to be 0.5 minus 0.2, which is equal to 0.3. Okay, so I'm going to go in the table, I'm going to go look up an area of 0.3. Okay, and an area of 0.3, okay, well, 0.2995. Okay, it looks pretty darn close. 0.2995. It's much closer than 0.3023. So that z score over there is going to be 0.84. Okay, 0.84, but it's negative, so this is going to be negative 0.84. Okay, so that the probability that x is less than 1.59, sorry, z is less than negative 0.84, you don't have to write this down, is going to be 0.2. Okay, right. So we said the z score is negative 0.84. Okay, let's check we got that right, because if we make a mistake early on, so it falls up. Yep, we're right. Okay, right. Negative 0.84 is that one over there. Right, and now I can get one equation, okay, using the yellow part of the sum. Okay, and I'm going to use z is equal to x minus mu over sigma. Okay, and we have got what goes together here. When z, we're looking for, so I'm going to say z sigma, so I'm going to get rid of the fraction. And my z score is negative 0.84. So negative 0.84 times sigma is equal to my x score that goes with it is 1.59. And I don't know the other two. Okay, so I've got negative 0.84 sigma. Here's my equation I get from that yellow part of the sum. So I need two, my objective is I want two equations with sigma and mu. Okay, right. So from this bit over here, okay, I need another equation. Okay, I need to find, well, first of all, I need to find the z score that goes with an x score of 1.86. Okay, and this area of 0.125. So in my table, okay, I can look up this area over here, and that area over there is going to be equal to 0.5 minus 0.125, and 0.5 minus 0.125, 0.5 minus 0.125 equals to 3 over 8, which is 0.375. So that's that area over there. Okay, so on the table, I'm going to go look up 0.375, and 0.375, well, it's pretty much this one over here in green. There's 0.375, which goes with 1.15. Okay, and it's positive, so this z score is 1.15. There's a z score of 1.15. Okay, right, and now I need to get a formula, okay, that goes with this. So if I'm using z is equal to x minus mu over sigma, and I'm using this green bit over here, okay, I'm going to have z sigma is equal to x minus mu, and my z score is 1.15. I don't know sigma, and my x score that goes with it is 1.86 minus mu. Okay, so to solve this, let's isolate mu. From this side, I get mu is equal to 1.86 minus 1.15 sigma. Okay, and on this side, I get mu is equal to 1.59 plus 0.84 sigma. Okay, so if I equate equation 1 with equation 2, and I let equation 1 equal to equation 2, or sub 1 into 2, I'm going to get 1.59 plus 0.84 sigma is equal to 1.86 minus 1.15 sigma. So I get 0.84 sigma plus 1, there's only one there, plus 1.15 sigma is equal to 1.86 minus 1.59. Remember, sigma and mu have to be positive. Okay, so I get 0.84 plus 1.15, okay, equals 1.99. So 1.99 sigma is equal to, so I'm just going to say 1.86 minus 1, I'm going to leave that there, 1.159. I hope I made a careless mistake, 1.159 And sigma then is going to be that over 1,99. Okay, and you should end up with sigma is equal to 1.86 minus 1.159. Okay, and I get 0.701 divided by 1.99. Wow, I'm feeling I made a mistake. Okay, and you get 0.35. Maybe not. Okay, so sigma is equal to 0.35. Let's check. No, I made a mistake. Okay, let's just check in the textbook quickly. Okay, you got my equations are right. Mu is equal to 1,59 plus 0,84 sigma. And here we get mu is equal to 1,86 minus 1,15 sigma. Okay, so you get 1,59 sigma. Okay, plus 0,84 sigma is equal to, okay, sorry, 1,59. So you get 0,84 sigma plus 1,15 sigma. Yep. So I just about did everything right. I must have made some killer. There's no 1 here. Okay, 1,59. Okay, I don't know why I put that 1 in there. Okay, so that's going to be 1,59 and divided by that. Okay, and you should end up with divided by 1,99. That's all right. So you get sigma is equal to 0,1357. Okay, and then all you have to do is plug sigma back into one of these equations over here. Okay, and we'll get mu is equal to 1,59 plus 0,84 times 0,1357. Lob that in, and we should get mu is equal to 1,70. Okay, so if you asked to find both, okay, mu and sigma, then okay, that's what you're going to do. All right, guys. Okay, hope that made some kind of sense. We'll do doing a live lesson in the second part of this double. Baie dankie aan Skade vir sy help. So dit is baie pragtig. Ons is baie gelukkig dat jy hier in die studio was. I hope it's making sense, all of this stuff. Okay, and we will see you later. Don't forget, try to do this some on your own. If you haven't been copying it out now while we're doing this, go back ideally and try to do it by yourself. Okay, and then you can go check in your textbook whether you got it correct. Okay, guys. Okay, have a good one. Tot ziens.